Testing of a clamping circuit. The aim of this experiment is to study the various clamper circuits and to plot the output waveforms for a sinusoidal input of given peak amplitude. The design considerations are: frequency is set as 1 kHz and peak to peak voltage is 8 volts. The components required for this experiment are cathode ray oscilloscope, signal generator, diode, resistor, DC power supply and capacitor. A clamper is a circuit which clamps or shifts the waveform to a desired DC level. If the waveform is shifted above the positive region of the reference line, then the circuit is called positive clamper circuit. And if the waveform is shifted below the reference line in the negative region, then the circuit is called negative clamper circuit. Basically, the clamping circuit adds DC component to the signal. This is the experimental setup of the clamper circuit. The input waveform is the sinusoidal signal which is provided to the circuit, and the output signal is sinusoidal signal which is shifted to the desired DC level. The output is taken across the load resistor of the circuit. When the polarity of the diode is changed, then we can get the negative clamper circuit. This is the circuit for positive clamping with the peak voltage of 10 volts, and the diode is placed in such a way for positive clamping. Here the input waveform is having a peak to peak voltage of 10 volts. Now the clamper circuit shifts the waveform in the positive region above the reference line, and we can infer that the output waveform is having a peak to peak of 10 volts above the reference line, that is in the positive region. Similarly, when the diode is changed with the polarity, that is forward biased, then we can get the negative clamping of the waveform. In addition to the positive and negative clamping, we have the biased clampers. Sometimes an additional shift of the DC level is required. In such cases, the biased clampers will be used. Here, the external DC voltage is provided to the circuit. This is the circuit of the positive clamper with negative bias. and this is the circuit for negative clamper with positive bias condition. According to the biasing voltage, the waveform will get biased in the positive region or in the negative region accordingly. The procedure for the construction of the circuit is: rig up the circuit in the spring board, increase the amplitude of the signal generator to 10 volts peak to peak or 8 volts peak to peak. Observe both the input and output waveforms on the CRO without applying the reference voltage. Apply the given reference voltage and observe both the input and output waveforms on the CRO for the biased clamper circuit. Measure the clamping level and compare them with the designed values. This is the experimental setup of the clamper circuit. Here, the capacitor is connected in series with the diode. The diode is connected in parallel with the load resistor. Now, let us configure the circuit with input and let us infer the output across the load resistor. The output from the signal generator is fed as the input across the circuit. In this CRO, channel 1 is assigned to view the input waveform and channel 2 is assigned to view the output waveform. The channel 1 probes are connected across the input terminals. Channel 2 is connected across the load resistor in order to view the output. Initially, the channel 1 and channel 2 are kept in the ground position and the waveforms is positioned at the reference line. Now, the signal generator is tuned for sine wave of 1 kHz. Now, we can view the input waveform as 8 volts peak to peak, 4 volts in the positive half cycle and 4 volts in the negative half cycle. The circuit is a clamper circuit. So, here, based upon the position of the diode, either the positive half cycle or the negative half cycle, based upon the position of the diode and the polarity of the diode, the waveform, the output waveform will be shifted above the reference line or below the reference line. Here the output waveform is shifted above the reference line. Based upon the position and polarity of the diode, here the output waveform is shifted to the positive region above the reference line, hence it is positive clamper circuit. Now if we reverse the polarity of the diode, then the waveform will be shifted to the negative region below the reference line. We can infer the output waveform is shifted or clamped below the reference line in the negative region. So this is the configuration for the negative clamper circuit. This is the experimental setup of positive clamper circuit with biasing. Here the input from the signal generator is given across the capacitor and the input probe from the CRO is connected across the capacitor. This capacitor is connected in series with the diode, and this diode is connected in parallel across the load resistor. Compared to the previous circuit, here we are giving an external voltage, that is bias voltage, to the circuit. So the bias voltage of 2 volts is provided to the diode. So here the negative terminal from the biasing voltage is given to the anode and the positive is grounded. Positive biasing voltage is grounded. If we infer the input waveform, then now if we infer the input waveform, it is connected with the channel 1 of the CRO. For 1 kilohertz, the input waveform is having a peak to peak of 8 volts. The output waveform is clamped in the positive region of about 6 volts. 2 volts biasing causes the output waveform to appear across the negative region of about 2 volts. Now, if we increasing the biasing by 4 volts, then we can see the output waveform is clamped at the DC level of 4 volts in the positive region and 4 volts in the negative region. Now, if we want the entire waveform to be shifted to the negative region, that is below the reference line, then we need to change the polarity of the diode and the polarity of the biasing voltage. We can infer that the polarity of the diode is changed and the polarity of the biasing voltage is changed. The positive is given to the diode and the negative is grounded. Now we can see the change in the output waveform. This is the input waveform. Now let us infer the output waveform. The output waveform is shifted to the negative region and we have given a bias of 2 volts. Hence, the entire waveform is not shifted below the reference line. It is shifted only by 6 volts below the reference line, and 2 volts biasing causes the 2 volts of the peak voltage to appear in the positive region. Now similarly, if we increasing the biasing voltage, we can see the corresponding shift in the waveform below and above the reference line.